All right. The new stuff has to do with elimination. Okay, you know how we used elimination to solve for your x and your y? Now we're going to have equations that have x, y, and z. Okay, now it complicates things a little bit, but the concept is the same. Now, this is stuff you want to keep extremely organized. I think we talked about before that you literally could graph this on a three-dimensional coordinate plane, which is like your three-dimensional printers, okay? Your z is your depth out, okay? But that's not really what we're interested in, but we are interested in the concept that these three equations, which all graph lines, are going to cross at one spot. And the x, y, and the z is what we're trying to find, which is the coordinate or the ordered pair for where it crosses, okay? We're not going to put them on a graph. I'm not that good artistic-wise. So, but we are going to algebraically solve them, okay? Could you solve them by graphing? Yeah, but like your calculator can't do it, all right? What you're going to have to do is you're going to have to put two of these together, eliminate out one variable. Then put two more of these together and eliminate out the same variable, and then put those two answers together. Okay, this is not, don't allow that much space for your problem. This is a whole page worth, okay? You got to give yourself some room here. So I look here and I go, okay, it really doesn't matter. If I'm looking at it, I'm saying the x is probably the easiest thing to eliminate out. Okay, because I've got 2's and I've got 1's, easy to make them have the same coefficient. So I'm going to take the first two. Now that's just going to be what I'm going to do. You don't necessarily have to do that. So when I take the first two, I'm going to rewrite them. All right, how can I make those x's have the same number in front but opposite signs? What do I need to do?
Multiply the first by -2.
Okay, I'm going to multiply this first one by -2. So I have a -2x plus -4y plus 6z equals -100. Now, be very, very careful. Because if you make careless mistakes on this, this becomes the never-ending problem with fractions and decimals, and you will not want to do it, okay? So make sure you are double checking your work as you go through. All right, don't have to do a thing to this one, so I have 2x, let me write it underneath there, 2x plus y plus 2z equals 3. All right, now I'm going to add. Now, if I've done it right, something should eliminate out, right? So this becomes -3y, be careful of your positives and negatives, plus 8z equals -97. I'm going to circle that because I'm going to want to come back to it. Now I choose two other equations. Doesn't matter which two I choose as long as I don't choose the first and second again. I can choose the second and third. I can choose the first and third. Doesn't matter. I'm going to choose the second and third. All right? So I've got 2x plus y plus 2z equals 3. 2x minus 5y plus 4z equals -79. All right. How do I, now remember I eliminated out the x's there, so I have to eliminate out the x's here. So what would I need to do?
Multiplied by -1.
Okay, just pick one. It doesn't matter which one. Okay? Let's pick the top one. Okay? Well, I'm going to multiply that by -1. So I have a -2x plus -y plus -2z equals -3. This one I'm just going to bring over. 2x plus -5y plus 4z equals -79. Okay? that eliminates, right? This is a negative 6y. This becomes a positive 2z, and this becomes a negative 82. With me? Now, these two things that I circled, I have to put together. Okay? Now I have to choose to eliminate out the y or the z. So I'm going to come up here. I'm going to do it in a different color. You can see where you're going to use some paper. Okay? Now I get frustrated with this because I don't have enough room on the board. But so I'm going to take these two. Okay, negative 3y plus 8z equals negative 97. And negative 6y plus 2z equals negative 82. All right, what do you want to eliminate out? X or y? Doesn't matter. I mean, not x, z or y. Y. Okay, let's do y. All right, let's multiply this top one by a negative 2. Because if I multiply it by a negative 2, it becomes a positive 6 and it's going to go away. Now, as strange as what this is going to sound, I would strongly encourage you to use your calculator on things like 2 times 97. Because you don't want to make a careless mistake. All right? 6y plus negative 16z is equal to positive 97. Oops, it helps turn it on. It's going to give me a positive 194 because it's a negative times a negative. This one is a negative 6y plus 2z equals negative 82. When I add it, the y goes away. This is going to give me a negative 14z. Okay, then I have 194 minus 82. And that's going to give me 112, which I'm going to divide by my negative 14 to solve it. And I'm going to get z is equal to negative 8. I finally found a variable. Okay, so there's one thing I'm looking for. Now I have to go back and plug that z in. I can't plug it back in over here because that would still give me two unknowns. But I can plug it back into one of those two down here that I have circled. Doesn't matter which one I plug it into. Let's plug it into the first one. So I have negative 3y plus 8 times negative 8 equals negative 97. Negative 3y plus negative 64 equals negative 97. I'm going to add 64 to both sides. That's going to give me negative 33. I'm going to divide by the negative 3, and I'm going to get positive 11. There's the second thing I need to find. How do you think I'm going to find the x?
Finding the original.
I'm going to go back to one of those original that has x, y, and z. Doesn't matter which one I choose. Whichever one strikes your fancy, that's the one that you should use. So I'm just going to use the top one. Okay, so I've got x plus 2 times 11 minus 3 times negative 8 equals 50. You with me so far? Okay, x plus 22 plus 24, because I have a negative 3 times a negative 8, is equal to 50. X plus 46 equals 50. X is going to equal positive 4. So, my answer, 4, 11, negative 8. How would I know if I got the right answer?
If you plug it
I
back
would
in,
plug,
yeah.
okay, I would plug all of them back in, but here's the key, guys. They have to work in every one of them. If you're going to plug it in, it has to work in every one of them, because these two might cross in a spot different than where that one crosses as well. So there could be an answer that just works in those two but doesn't work in all three. You're looking for where all three of them cross, so it has to work in all three of those. Does that make sense? Okay. Not every problem is this complicated. Some of them, very quickly, you can find the x, the y, or the z. Let me see if I can find one where that's the case. Here's one. Keep your problem organized. Make sure that you're circling things so that you can quickly see it. These are not the kind of problems that you want to stop in the middle of and go to the bathroom or go get popcorn, or because you'll forget where you are, okay? So when you start one of these problems, you need to finish it to its end, okay? Otherwise you're gonna get all mixed up. If you make a mistake and you think, oh, this isn't coming out right, because I will tell you whether it comes out to be a whole number or not before you go to do your homework, because that sometimes helps. And if you get a fraction and it's supposed to be a whole number and you go, oh man, I made a mistake here. Sometimes it's easier to just restart the problem. Because with these kind of problems, if you make the mistake one time, you're more likely to make it the second time when you do it, looking at it, okay? All right, looking at this, I have 3 equations here. There's one. All right, how is this different?
There's no X in the bottom two.
There's no X in the bottom 2. Okay, so look guys, could I not just put these bottom 2 together and eliminate out either the Y or the Z and solve for the other one? Okay, depending on the equations they give you, you've got to be able to adjust. All right, so I'm going to put these 2 together. So I've got 4Y minus 3Z equals 1, and Y plus 5Z equals 6. What do you suggest I do?
Multiply the bottom by 4.
How about we'll do by -4, okay? So I'm going to do the bottom by -4. I'm going to move this one on over, so I have 4y minus 3z equals 1. This is going to become -4y plus -20z equals -24. Okay, with me? All right, those cancel out. This is going to give me a -23z. This is going to give me a -23. What does z equal to? 1. Okay, I know that one. How am I going to find another one? Okay, can't do it up here yet, but I could do it on one of those 2, because then that would just give me one unknown. You can only solve for one unknown at a time. So, let me put it back in that one. I have 4y minus 3 times 1 equals 1. So I have 4y minus 3 equals 1. I'm going to subtract, or actually I'm going to add. So I have 4y equals 4. Y is going to equal 1. Okay? So I've got the y and the z. Now I go back to that original and plug in. You with me? Okay, so I have x plus 2 times 1 plus 1 equals 4. X plus 2 plus 1 equals 4. X plus 3 equals 4. Ah, x is equal to 1 too. All right, so my answer is that. See how that's a little different? Much quicker than the other one. So it just totally depends on what they give you. Now, if you got down to the end of a problem, and all of a sudden you have things that cancel out in your problem, and like you've canceled out, let's say I put it up here, and everything cancels out. Okay, I no longer have y's, I no longer have z's, and at the bottom, I have, let's say that became a positive 3z. And you go, oh, that's gone too. I get 0 equals -23. Is that true? Okay, so what do I know about these 3 lines?
They're the same.
They're not the same. They don't have a point of intersection. So what are they?
Parallel.
They're parallel. All 3 of these lines would be parallel, so they would never cross. Now, Joseph's onto something, Okay, so if I get something that's not right at the end, then I know that it's an empty set or they're all parallel. But if I get,
0, 0.
right, if I get 0, 0 at the end, then what do I know?
They're the same.
They're the same line, okay? And it's infinitely many solutions, okay? Does that make sense? Okay, kind of like the ones that we did before. Okay,
But wouldn't you think that would be 0, whatever the z-axis would be?
do what?
Wouldn't it be when they still have a z-axis?
On these two, truthfully, it would depend on the problem, but most of the time you're not going to. Okay, you could have three-dimensional that they're all parallel. So typically, if two of them turn out that way, all three of them are going to be that way. Okay, you might actually, and this one didn't work out well to do it, but you might actually have one that you put the two equations together and all three of them cancel out. Okay, not very often, but occasionally. All right, I am going to give you one to try. Okay? Let's go to it. I don't know that you'll get this done. They're not short problems. And let me, before you start on it, let me make sure that I copied it right, because that would be a painful thing. Okay, 1 second. All right, and I will tell you, these come out to be whole numbers, okay? So if you do them and you get a fraction, something happened, okay?